Hey, and welcome to this introduction to Excel. In this session, we're going to look at Goalseek. So we've seen before if we do a function, when calculations, Excel is very useful to make calculations efficiently. And that's why we use references, and that's why we let Excel calculate for us. So for example, we see here, we can take b6 b6 plus bc6. We can add things here that can we see Excel can add. So let's look at a different version of this. Let's see what happens if we have an input and an output. And what should our output be? Well, let's have our output be the square of something. So we square something. If we square something, for example, if we have 2, what is the square of that? Well, that would be 2 to the power of 2, then, right? Whatever the input is to the power of 2. We can also write, if we want, our cell multiplied by itself. That is the same as squared, right? So 2 to the power of 2 is 4. 6 to the power of 2 is 36. So obviously, for easy numbers, it's quite easy. 1244, 15225, and so on. But we can also do more, bigger numbers, and it helps us do it quickly. So that's a nice thing. We'll also align these to the right. We can make them bold and give them a little line here to make it look slightly nicer. Now, so with the help of this, Excel can now do a very basic thing, as in, what is the square? What is 65 squared? 65 to the power of 2, it's 4,225. Excel does it instantaneously for us. What's 70 squared? Oh, it's 4,900. What's 51 squared? Oh, it's 2,601, and so on. But sometimes we don't. So for these kind of questions, Excel helps us a lot. They do the calculations for us. But we could ask a different kind of question. So we can ask the question not as what is 4 squared, but instead, what do I need to square? So what is 4 squared? So then we say we have the input is known, but the output is unknown. And we ask Excel to tell us. The input is, what is 5 squared? The input is known, it's 5, but the Excel gives us what the output is, 25. But it could be the opposite, so that the output is known, or we know what we want, but the input is unknown. So for example, what do we need to put in order to get a certain square? So what do we need to put in to get 16? So, well, if we put in 4, we get 16. So what do we need to put in to get 16? And that is sort of the opposite, right? Instead of having our input known, we're going to put in this and get something out. The input is unknown, and we want a specific outcome. Now, we could call that the inverse, right? We want to take the inverse of this function. Instead of doing it this way, putting this in and getting that out, we want to go the opposite way. Now, some things you can take the inverse of directly. What is the inverse of the square? Well, that's the square root. So we could just take the square root. So in this case, if we want to do the square root, we could, I'm just going to copy this, Control C, paste it in here, and instead of square, we take square root, or the square root. I can do like that. And if I switch there, it will go into there, the square root. So in that case, I'll put input, so I put in 16. I'd want to get the square root. It'd be this to the power of 0.5. That's the square root. Or alternatively, there's even a function, sqrt, that is the square root of this 4. And okay, that's great if we have a function that is the inverse of our function. But that's not always the case. It's not always the case that it's that easy that we can just reverse the function, reverse engineer it, go backwards. So sometimes we have complex functions, but we still have, an outcome we want, but we don't know what the input is. What do we do then? Well, in that case, we'd have to guess. So let's take a question here. Like, okay, what do we need to square in order to get 36? Well, that's easy. That's 6. We know that. In that case, in those cases, it's easy. but it could be more difficult. What do we need to square in order to get 450? So 400, okay, that might be more difficult, but you know, if we think for a bit, we realize, okay, that's 20. 20 squared is 400. But 450, that's more difficult. What would we do in order to get that? Well, we'd have to guess. I mean, we could use the square root and mathematically work it out on a sheet of paper, but if we don't want to do it that way, we just have to guess. We take a number and square it and see what we get. So it takes 20, we get 400. Now that's less than 450. So what do we want? What's our, can I say as a goal? 450. And I remove these lines here, and I can add a line there. Looks nice. So in order to get 450, we put in 20, which we guessed 20, we got 400. That's a little bit too little, so we want more. Okay, we guess 30. Now we get 900. That's more than 450. Okay, so it should be between 20 and 30. So we guess 25. That's 625. That's still more than our goal, 450. So it's probably between 20 and 25. So we halfway, we guess 22. Ah, now we're quite close. 484. Still more, but close. So it's between 20 and 22. We try 21. Ah, now we get less. So it's between 21 and 22. So we try 21.5. We get more. We try something less. So we try 21.25, for example, just 21.2. Oh, now we're very close, but still a little bit under. So we increase this a bit. 2. It's too much, so we decrease this a bit. About 1.5 instead. Now we're getting close, and so on. So we can guess our way forward by just putting in different inputs. Now this is something that Excel can do for us and can do it really well. Why? Because these are very simple calculations that Excel can do, and that's what Excel is good at, is doing simple calculations and doing it simple calculations quickly and doing a lot of them. So in order to do that, we go here to the data and go to what if analysis, and here we click Goalseek. Now Goalseek does this. It's exactly these kind of questions it answers. It says, we have a certain cell, in this case this one. We want to set it to a certain value, this one, but we can't click here as we see. We have to write in the value manually. So write in 450 by changing another cell. What cell do we want to change? Well, if we click this one, this cell, what happens? Nothing. Why? Because this cell is not connected to the cell we're interested in. So we see here, if I put in 40 here, nothing happens to this cell. If I put in 20, nothing happens. Excel will try to test a bunch of numbers and nothing will happen. It will get frustrated and say, hey, it doesn't work. But if we say we want to set this cell, this is what we want. This is our output. So always put the output here by changing to a certain value, 450, for example, by changing our input cell. Now, it needs to be in this way, because let's say if I'm not changing my input cell, but a random cell, well, it doesn't make a difference, because if I can put whatever numbers here, it won't make a difference in that cell. If I put this cell itself, D6, the same one, well, that's trivial. I want cell D6 to be 450, and I will want to get that by changing cell D6. Well, I just put in 450, and it'll be done. No, it needs to be the input cell that I switch, the one that I'm testing numbers in. So that's the one I put in. Try testing numbers here. I'm telling Excel, test numbers in the input cell and see if you can get this cell to be 450. So we're trying this and see what happens. So I test various ones. We see all here, and it gets an answer. Does it get the exact answer? No. In the case of 450, sometimes it can get an exact answer. But in the case of 450, we see that the square root, the number you need to put in here, is an irrational number. That means it cannot be represented in decimal form. That means we can't see it in this way. So they're not going to get the exact number, but instead Excel will get a number very close to our number, because they'll get an output that's very close to 450. And we see here what it got. It says where we're looking for 450, that was our target, we actually got 449.9999604. And we thought that was good enough, so we're happy. That's what Excel says, or Goalseek says. So if we accept that, we click OK, and it keeps this input. Now here it says 450. Why is this? That's because we have a certain amount of decimals. If we increase the decimals, we see here that it's not exactly 450, but a certain amount compared to our goal. So, and here's our input value. So why doesn't it go closer? Well, you can calibrate some of those precisions, but one of the reasons is Excel is limited to a certain amount of decimals. I mean, it can't do infinite decimals, and if it does a lot of decimals, then that would take much more computing power. Excel would be slower and so on. So there's a trade-off. So it cuts it off at, in this case, 4, 8, 12, 13 decimals. And at these two numbers, we have 15 characters, and we also have the comma here. So it has to do with, I think it's 2 to the power of 4 amount of significant digits. Okay, and we see here, so here if we change that to 7, will this become better? Maybe. We see here, did it become better? I changed it to 7, I changed it to 8. Oh yeah, see, I can change it maybe even up here to 8. We can get an even better number. So we can guess around. We see that when it comes to this, Excel actually accepts it could have a greater precision with these numbers, but at some point it has to be done. So it says it's happy, and we get the result. Okay, so that's how we use Goalseek. We use it specifically when we say we can't get the question directly. We can't put ourselves 5 squared. What is that? We just add it, we get it. But instead, we say, what do we need to put in order to get a specific output? When we ask that kind of question, that's when we use Goalseek.